I'm going to present our battery-powered connected device that monitors and registers temperature and relative humidity. Because we have to know that although we have temperature set points configured in our control units, in our refrigeration installation, the actual conditions that can be in the room, in the cabinet, or in the place we put our products can be quite different. So AKODATA is a system that allow us to verify and audit that these conditions, the desired conditions, are real and taken in place in the location. In addition, AKODATA also brings the possibility to get alarms, events, and all kind of notifications when specific situations of the cool conditions are reaching some aspects that should drive to a notification alarm that would be provided to anyone. Basically, this device that is cable-free is easily installed in the location where we want to measure the conditions, and we can provide not only current up-to-date data about the temperature and relative humidity, but also we can bring some contextualized information about what is the range of this of the situation in my installation. For example, here we can see that the temperature is 4.5 degrees, but we also see the range because conditions inside a refrigerator system are not constant, so we have a variation among time. Also, we can see this kind of variations in humidity. Some additional information can be provided thanks to the fact that the information is uploaded to the cloud, and also some calculations are done, so we can provide more decision or data that can be used for decision making. For example, we can provide easily percentage of time in range and time out of range that can support us if, and we can easily decide if these conditions are good enough or should drive to a modification or correction. We can in the other screen also provide information more from the business side. In the example we provide this second dashboard is providing how the conditions of temperature and humidity and the variations during all the time are affecting the products that we have inside the location. For example, variations in temperature could cause aging, an acceleration and different speeds of aging of the food. For example, if we can understand fresh fish can be affected if the temperature gets a long range of variation, and also different humidity conditions can bring to a drying acceleration of our food. This information brings a lot of value to our customers if they can use this information to decide if the actual condition in their facilities are affecting negativity to the quality of the products. We can provide some examples about how the data provided in our platform can help us to easily detect how the conditions are and correct if necessary. For example, we have an example of a butchery cold room, and in the information provided here, we can see that the butchery cold room most of the time is in green. This means I am inside the range, the desired range between minimum and maximum threshold, temperature threshold. But we can see that also there is a considerable time below the minimum threshold, and only a few times, very small times, over the maximum threshold. This is combined with information provided here that we have maximum and minimum threshold. We can see there is a considerable amount of time that my products are below temperature, that are not probably also are affecting quality in my product, nearly freezing conditions. And this kind of visualization helped me to understand that probably we should check that the set point, temperature set point in my control needs a correction, just to move this graphic a little bit right and put most of the time between the range that is desired. This will, of course, causes a reduction in the energy waste that this facility is having, and also we will keep the product inside the ideal conditions, and best quality will be provided for our customers, for our consumers. A second example about how this can be easily, how the data provided can be easily addressing a correction would be a fish cold room. In this example, we can see, and we can even understand how the behavior of this cold room is being during the day. We have small peaks here. These small peaks, we understand that are the defrost. Every installation needs a defrost to avoid ice and to get ideal conditions. This defrost is quite normal. As we can see, temperature is not being dramatically affected, but we have a big peaks here. And easily we can understand that this cold room is often with the door open. And this opening door quite often is causing a decreasing of the temperature inside the cold room. As we can see here, the owner of the facility decided to check or to decrease the temperature set point. So most of the time, the cold room is in the minimum temperature area, and we have this prolongation or this extension of the temperatures to the positive side. These are the continuous opening doors during the day. So finally, we have detected a bad practice. Probably the use of this cold room is not good enough, and my personnel, my operative people in the facilities opening door too often and too much time, and this is affecting the behavior of my facility. So as we can see, we are probably affecting the product quality and also provoking or causing a higher energy consumption that could be easily correct if we implement best practices, like, for example, controlling time of these door openings. Another example that can be easily seen is this frozen chest. In this case, the owner of this facility was selling shellfish that was being frozen in this frozen chest. As we can see easily, most of the time, the temperature of the frozen chest is in the upper side of the temperature. So we can see there is no an equilibrated situation of temperature, and most of the time the product is in the maximum temperature side. So product quality is being affected. And finally, the situation is that this owner was upset because he was not selling products real well. Finally, when he put this, he realized that most of the time temperature was not ideal for him, and he decided to control the set points and get a lower temperature that could ensure the quality of the product. In this case, we are not bringing efficiency, but we are improving the quality of the products, and finally supporting him to sell more products to the customers. And another example could be in the side of alarms, events, and notifications, because these devices are constantly tracking and registering temperature. I can decide when a specific event needs to be notified to the people that is in charge of these facilities. In this example, we can see a singular increasing of temperature in the location, not normal, something must be done. So we understand immediately that when this happens, we have defined a process to send a message to my maintenance team. I need my maintenance team to come to my facility to make something. But in addition, the notification was also sent to the owners of the property, and they decided to go to the supermarket and take the products in this cabinet and take them out and put it in another facility that is working properly. So meanwhile, the maintenance guys were going there and taking the repairman of the facility. The products were not being affected, and when everything was done, several hours later, finally these products could be put again in the facility and keep business as usual. This is an example also about how these kind of devices can help us and avoid problematic losses and economical impact in my activity. So what we achieve with these kind of devices? Well, first, and very important, a lot of people is taking this registration manually. We avoid this kind of manual registration, and we introduce a system, very easy to install, very non-intrusive system that can be put, plug, play, and get instant data in my platform. So I can implement from one day to another a system that send me real-time alarms, events, and notifications. I get trustful, contextualized, and business-driven information. And when finally I have a platform that is easily scalable, I can have multi-site, multi-location views of my entire facilities and easily integration with third-party systems. Just to end, an example about a real food retailer that has in a specific hypermarket of 12,000 square meter, we detected 66% of bad practices, nearly 2/3 times of activities that not were properly done. We improved 35 of incorrect settings that were driven to increasing energy consumption or affecting product quality. The project was real, had a return in less than 1 year, and in this specific location, additional savings were of 5 figures. So finally, we understand this product, this connected and smart product, easily bring returns to our customers.